XYZ tiles, you will find OpenStreetMaps. Okay, so if you have found it, just drag and drop. Okay, so this is your OpenStreetMap, right? So right, I hope you have all have found this option here in the under the XYZ tiles. Okay, so this is basically your WMS layer. You cannot make edits, you can just use it as a base map. Okay, so next is, let's open our data. Okay. So what we do, either we go to layer, add layer, and select add delimited text layer from here, right? Or we have our side toolbar. We have our side toolbar in which your first icon, which is open data source manager, helps you in loading your CSV file or other types of file as well. Okay, so click here. Okay, and in this window find delimited text. Okay, right, and using this first file name, here you have to provide the file name. Okay, and you have to provide this file name using browsing through your folder. Okay, so click on three dots. Okay, and if you have saved your project, it will direct you to the folder. Okay, to your project home folder. So click here, load accident data CSV, click on open. Okay, and see, it is counting the records. Okay, so it is counting the number of records. It has, I think, approximately 5 lakh records. Okay, on crime data. Right, so again you have the file format, right? So you can custom your delimiters. If your data is separated by tab or semicolon, comma, colon, or any other sort of delimiters, then you can mention here. Okay, and after that, as I said, you have to define your point coordinates. Okay, longitude and latitude. So the geometry, current CRS geometry is 4326, so let's keep it in the same way. Okay, so once you are done, you can also have a look into your data in this sample data table. Okay, right, so once you are satisfied with all the parameters in this table, then click on add and then click on close. Okay, so it will take some time. Yes. Okay, so you see the data is loading. Okay, just zoom in and see. So as I said that heat maps helps us in aggregating the lot of point data. Like actually it aggregates the point data which are like huge in amount. Okay, so this is the example. You cannot make anything out of it using the graduated symbology, because these points are so close to each other, they will just overlap even if you use a graduated or categorized classification. You can try that. Okay, definitely you can work with that. So let's move ahead. Right, okay, now we have loaded our CSV data, right? So with this, this is your road accident data. Let's look into the table first. Okay, so before you do any analysis, this is the basic thing that you should always look into its attribute table. You can also check this table in your Microsoft Excel. Okay, but if you haven't done it there, just use this open attribute table. Click here. Day of the week, Thursday, Monday, on which day this accident happened. Okay, and what was the junction control, give way or uncontrolled or auto traffic signal, what was the what happened at the junction. Okay, so junction detail, was it crossroad, was it T or staggered junction. Okay, accident severity, how serious or how slight the accident was. Okay, so remember this column, we are going to use this in our analysis. Okay, so there are latitude and longitude values, ride conditions. Okay, and there are some other factors, number of vehicles, how like number of vehicles involved in the accident. Okay, and some surface conditions, whether the surface was wet or it had frost. Okay, and what was the speed limit and time, and other things. Okay, vehicle type. Okay, so all these things. Okay, now let me close this window. So when we have analyzed our data, Okay, so because we know we have a lot of point data, let's find out the hotspots of the events, hotspots of the accidents here, right? So what is happening exactly here, right? So for that, our first method, as I said, we are going to use our layer styling panel. Okay, so click on the layer for which you want to modify the layer styling. Okay, and if you do not have this window open, then click on the first icon here. Open the layer styling panel. Okay, and then you make sure that this particular layer, the layer that you are modifying, is also selected in the first row. Okay, and here in single symbol, use this heat map. Okay, click on the heat map. It is done. Okay, so it took some time, some seconds, and then it is done. Okay, then after that, we all know that we can change the color ramp. Okay, we all know about it, what is color ramp and how it works. Okay, so let's come I'll come back to it later when we have when we have decided on these parameters. Okay, so radius is the what is radius here? Okay, so we know that circle has a radius. Okay, and these hotspot zones, if you can see, they are in the form of circle. And here I don't know if it is visible to you on my screen, but in your screen, if you will see, it has got some pixelated regions. Okay, some crisscross regions. Okay, so think about it, and then let's define radius. So radius value is actually, it determines the circular neighborhood. Okay, your circular neighborhood around each point. Okay, around each point where that point will have an influence. Okay, so assume a situation that you are living in a colony. Okay, in a apartment or in a society. Okay, where one incident of robbery happened. Okay, now don't you think that the entire society will be influenced? Okay, right? So so this is the kind of psychological influence, right? Psychological influence. But suppose the thief have the robbers have found out that that this particular region have not so tight security. Okay, so there is some leniency in the security is somewhat lenient. Okay, right? So next incident, there are chances that the next incident will happen again there. Okay, again in the same society, maybe in the some other house, right? And so in this way, if you will see, you will see, if you find out the data, crime data or robbery data in a particular society, then it is, you will see that it is getting influenced by one of the incident. Okay, so the crime rate or the robbery rate is increasing. Okay, increasing, it have increased in a month or have increased in 6 months because of this particular reason, right? So this is also happens in every type of data. Okay, so having this in mind, so this value, largely it depends on the type of your point data. If you cannot understand this thing, you can ask me to repeat again. Okay, don't worry about it. So let's say, right, as I said that there is a robbery. Okay, and now we want to know what was the influence of a particular event in, let's say, 1 kilometer of the location. Okay, so if you want to know the 1 kilometer of the location, then here you will change the value, increase this value, right? And this radius, actually this radius value, when you put this radius value, the hotspot will be created around that radius. Okay, or this dark spot, or if you say this dark spot or these lighter spots will be created around this value, and it gives you an idea on how dangerous a particular clustering or density is. Okay, or how not in case of rob accidents, or in case of crime, we can talk about the dangerous. Okay, but if you have the clustering of houses, right, you can say how how dense this particular area is. Okay, so this radius depends on so this is based on the value of the radius again, and is estimated on incidences, right, are falling within the given radius, and that number determines or estimates how dangerous every point in your area of interest is. Okay, so again, this information that you decide, okay, it depends upon the knowledge that you have from the area. Okay, how much you are sure about your area of interest. Okay, if you know from the historical data, okay, this particular incidents have influenced at least 10 kilometers of the radius. Suppose if I say about the atomic bombing, or nuclear bombing, right? So you know that it can affect thousands of kilometer of area. Okay, so this is the radius. I hope it is clear. So this value actually, it gives you an idea about the area of influence of a particular incidence. Okay, and if particular point falls within the radius, we will say that it is more dangerous than it was if it was outside the radius. Okay, is our weight points by. Okay, now as I said, in our attribute table, if I go back to our attribute table, okay, so there in this table there are different type of accident severity. Okay, some are serious, some are slight, and some are fatal as well. Okay, if you look into the table, there are some fatal accidents as well. Now, so the thing is that you can also give weightage to your factor. Okay, you can also weigh your points, right? Suppose you want to say that let's start from here, that suppose when you just want to consider the point density, then of course you can stop here and plot the map. I'll tell you how you can beautify this map as well. Okay, right? But sometimes what happens that we want to give weightage or importance, let's say in simple language, to one factor over the other. Suppose if accident happens, of course I will be more concerned about the cases that are causing fatalities. Okay, and in case of crime, I will be more concerned about the rape incidences or the murder incidences than the robbery. Okay, this is my concern. This concern can vary from one person to another. This importance or the weightage can vary from one city to another. Okay, or one incident to another. Okay, this is completely independent choice. Okay, but in this case, if we consider the fatality above the slight accident incidences, then of course we are going to weight our points, right? We will give more weightage to the fatalities. Okay, we want to do that. So so we have to find out, is there any way we can do that? Okay, yes, we can do that by creating some conditions. Okay, we have to understand how expressions are helpful in or how field calculators are helpful in creating some conditions that we have in our mind. Suppose you have another condition. Okay, so how you can apply your condition in QGIS, and how you can create your expressions for that. Okay, and based on that particular field, you want to put give you want to plot your final output. You want your final output to have that that particular weightage. Okay, so for that, let's open our attribute table again.
Excuse me, ma'am.
Yes.
Ma'am, is my network is poor or is actually the black circle is blurry or hazy?
It is blur.
Oh, it is blurry.
Yeah.
Okay.
It is slightly blurred. This looks something like that. I'll show you how you can beautify this. Right now we are just focusing on the parameter calculation and understanding them.
No, actually, okay. Actually, I thought my network is poor.
No. Yeah. Okay. So as this is a CSV data, this is your CSV file. You cannot toggle edit it. Okay. You cannot go with this. So let's add our field calculator. Okay. So click on open field calculator. Okay, and we will create a new field. Let's say that will be our weight. We want to give the weightage to our accident severity. Okay, I have already made this. Okay, so but how can you make this for yourself? Okay, because as I said this is a condition. Okay, this is a condition that we are going to put in this expression. So you will go to conditionals. Okay, so whenever you want to put any sort of condition in QGIS or in calculation, then you go to conditionals. Okay, so double click on case. So you are giving it a case. Okay, so if you want to read more about the case, what it says, it is used to evaluate a series of conditions and return a result for the first condition met. Okay, the conditions are evaluated sequentially, and if a condition is true, the evaluation stops. Okay, so let's first understand how we give condition, and they have also given you the arguments. Okay, so when condition, if you apply when condition, a condition expression to evaluate. Okay, you are telling QGIS to evaluate that particular condition. Then result means then will give you the result. Okay, else is for otherwise. Otherwise, if these two things are not present in our in our given values, given fields, then return this else value. Okay, for example, they have also given you the examples here. Okay, you can go through it, and I'll try to make you understand how it works. Okay, so let me remove this. So with case, you always add when. Okay, case when. Let's click enter here. When. So when we will define our condition. So we will go to our fields and values. Okay, is am I like the speed is fine, right? Okay. Yeah, so the case when our accident severity, okay, so we will read it in our simple language as well. So case when our accident severity, okay, accident severity, let me go back, okay, severity is, let's get all unique values here. It should give some unique values. Yes. Okay. Fatal. This spelling is wrong. It is saying fetal. It should be fatal only, serious and slight. Okay. So case when accident severity, then you give it like. Okay. If it is like fatal. Okay. If it is like fatal, then what we have to do? Then we will give it a weightage. Okay, then let's say we want to give it a weightage of 10 points. Okay, so if the person has 100% attendance, so this condition is something like that. If a person have 100% attendance, then give him or her 100 marks. Okay, so this is similar to this situation, right? Okay, so next condition is when. You can also type these things. Okay, if you are not able to find it, when. Second condition is accident severity is like, okay, serious, then type this value, and then you want to go with, let's say, half of this value, half importance you are giving to when the accident severity is serious. Okay, next, else. Let's use else. Otherwise, if both these conditions are not met, okay, in the field, if you do not, if we are telling QGIS, if you cannot find the accident severity like fatal and accident severity like serious, then else to other values, else is 1. Okay, let's keep it 1. Let's keep it the least weightage. Okay, right, or you can also give values according to your your wish. Okay, you're like independent to do that. Okay, after this, when it is done all the analysis, let's, and also you have to tell the QGIS to end the processing. If you cannot find any of these, you can go and end this analysis. Is it clear what we are doing here? Please say yes or no.
Yes, ma'am.
Okay. Yes, ma'am. Okay, great. Okay, so I think this was very simple, and you can learn more about this expression writing. Okay, in, I'll give you some website address, and this is actually your QGIS official website from where you can learn about these cases and all these language. So if I talk about the language that we have used here, so this language is similar to SQL. Okay, this is structured query language. This is similar to that, but it is not SQL. QGIS have its own simple expression language. Okay, and this expression language, this sort of expression language, it is used also for labels. If you want to, put expression for your labels. Okay, if you want to customize it, other than the options are already by default given by the QGIS. If you want to customize it, then you should always use this expression. Okay, and if you want to define your symbology, you can also use these cases. Okay, and if you want to put rule based rendering filters, okay, and then you can also, like, if you want to create some rules like that, then you should use this expression, and all the options are actually available here. Okay, everything is, whatever you have to use in, whatever you will need in QGIS expression, everything is available. Okay, you just have to go through it. Okay, so after we are done here, then click OK. So when you're practicing, you can also clip the like some data. Okay, you don't need to go, see, this is this table, taking one thing at a time. Okay, so when it is done with 10, if it cannot find 10 value, sorry, accident severity like fatal, then it will go to accident severity like serious. Okay, else it will end. Okay, I hope this is clear. See, you got the column of weightage. Okay, and it has provided the weightage according to the severity of accidents. Okay, now let me minimize this. Okay, so now we are going to weight our points by weightage. Okay, now this is our final result based on the 10 millimeter radius, because 10 millimeter is quite less. I know, I understand that, but here I don't want to disturb this value. Okay, now let's go to layer rendering. Now when we are done with all the parameters here, okay, let's go to our blending mode. Okay, you can blend it, and let's see what we get in multiply, how it looks. So one limitation I think I should discuss here is that you will not get the legend. Okay, you will not get the legend. See, when you have multiplied, now you can see the hotspot. Okay, hotspot is near London, right? So this shows that there are a lot of crime, different type of crimes. Okay, and based on your weightage, there are a lot of crimes happening, sorry, lot of road accidents happening in London. Okay, I hope this is clear. And in other cities like Birmingham and Manchester, and this is some other city. Okay, so these crimes are like, can you see this exponentially decreasing? So there is a huge spot here, but here you do not have that, darker color or darker hotspot. Okay, you can change the color ramp. I'll switch this off. I hope this is all clear. Okay, and you are going to experiment with all these values by yourself. Okay, so let me close this. Okay, next is our interpolation. We perform this heat map Kernel density estimation. We have to reproject our point layer. Okay, so let's duplicate this layer. Okay, I have to, yeah. So why this is important, I'll tell you. And let's say we will put the copy, and we will again modify this, one of the layers. You can choose any of them. Okay, I'll go to the single symbol. Okay, I'll put the single symbol for one of the layers, and this layer we are going to use for our kernel density. Okay, so we have to reproject this layer. If you remember from our vector analysis exercise, we used processing toolbox for for reprojecting our vector layer. Okay, so let's type reproject here. Here in the processing toolbox, okay, double click, right, and we are going to use road accident data, not the copied one. You can use any of these. So here your target CRS is actually your, just type in your in the here in using this icon here. Okay, so you have, if you, because I have used this CRS, that's why it is displaying on the this drop down menu. But for you, if you cannot find it here, you go to select CRS, okay, and in filter type EPSG, okay, 277, okay, 27700, okay. So this is your CRS for, see, when I'm clicking here, it is taking me to the United Kingdom. Okay, so this is the CRS, or this is the projected coordinate system that is defined for British National Grid. Okay, this is defined as British National Grid, and this is a very good CRS for the choice of data in UK. Okay, if you are working in United Kingdom, then you should always use this CRS, and if you go with this CRS, your estimations or your measurements will be accurate. Okay, more accurate, if more accurate than if you use the WGS 84. So this is, you can see the national CRS for UK. Okay, I hope this is clear. So that's why we are using this particular CRS. Okay, then after this, click on run. Okay, so once you're done, so click on close. So now we have reprojected our point layer. So why we have reprojected it? Because in this kernel density estimation, we will use the distance. Okay, so and distance plays an important role in computation of heat map when you are using interpolation technique. Okay, and in that case, it is not correct to use your geographic coordinate reference system. Okay, so that's why we reprojected our layer to this particular projection system. Okay, which is specific to the United Kingdom. Okay, let me close this again and let's go to interpolation. Okay, so we will use this heat map kernel density estimation. Double click on it and you will get this window. You can read about it here. So they have given a brief description of what this thing is all about. Okay, so we are going to use the reprojected layer. Okay, so the radius, let's keep it by default whatever it is. Okay, because this can cause problem in like in the training session. Okay, I don't want to be experimenting because it can take a lot of time. Okay, let's keep it default, and this is your pixel size. Okay, 0.1 by 0.1. Okay, 0.1 meters, it is giving us the value in 0.1 meters. So let's go with 30 by 30 meters of pixel size. Okay, again, if you have any value using which you want to define your radius, you can use anything like that, like the speed limit. Of course, we cannot define the speed limit. If you have any value, any weightage sort of thing, if you want to define your radius by some value, you can go with the field, and weight from the field, we are going to use the weightage. Okay, so this kernel shape is important if you try to understand it. So there are different, kernel is like a window. Okay, suppose you have one point which is your known point, okay, where you know the value, and you have another value, let's say in 100 meters, because here we are giving 100 meters radius. In 100-meter radius, you do not have any other point or any other data, right? If that is an unknown point for you. So how you want to interpolate your known value to the unknown location, that is defined by the kernel shape. Okay, that is like a window. That is, whether it should be linear, whether it should be uniform, or whether it should be quartic. Quartic is for your quadratic sense, right? In which you give some power to your data, whether you want this to be, go from 1 raised to the power to the 2 raised to, like 1 is, sorry, 2 raised to the power 2 or 3 raised to the power 2. Okay, right? So if you, whether you want to give it exponentially, whether you want to give it linear, right? You want your data to be spread linearly, okay? Whether you want your data to be spread uniformly, right? So you can use Kernel shapes according to this. So this is gives this is your uniform. This red is for uniform. If you have if you think that the influence of particular incidents is uniform throughout the radius. Okay, if you think it is uniformly spreading some disease, let's say there is, okay, let's take the example of COVID. Okay, if you think because we know that COVID spreads at very it spreads drastically. Okay, so of course our this is not going to be uniform. Okay, this can be exponential growth, this can be logarithmic or exponential growth. Okay, so here your quartic or your triangular or uniform window will not work. Triangular shape works when you think, when you know that your data is spreading linearly. Okay, uniform, you, as the name suggests, if you know that your data or the influence of particular incident is spreading uniformly. Okay, so in the case of COVID, of course uniform will not apply. Okay, and it can and triangular will also not apply, because we have seen the exponential growth of the COVID cases, right? So this is what you know helps you understand the this is what Kernel shape is all about. So if you want to understand the Kernel shape, okay, so we will keep it quartic, whatever default is. So first we have to understand that how large an area will be affected from an incident. Okay, and second, how much effect you think, or you with your with your experience, or with your technical knowledge, or with some, yeah, you can say the experience, right? So with your experience, you think that will remain at the original location. Okay, so the spread will be more at the original location, and how much you think will be dispersed, okay, to the other location, to the unknown point. Okay, that is completely depend upon your understanding, depend upon the understanding of the data, understanding of the literature, understanding of the history of the incidences, right? If next COVID wave like it if it comes again, okay, we know that the spread is like exponential, right? So we will take care of that thing in our, when we are putting lockdowns, or when government is deciding something on, right? So I hope this Kernel shape is clear with you. And this decay ratio is actually, it applies to triangular kernels only. If your data is decreasing, or it is having less influence in the unknown parts, and it is decreasing linearly, it is decreasing or decaying linearly. Okay, in that case you will define this ratio. If you think it is decaying exponentially, then you can give that exponent value. Okay, is it 2 or 3? That again depends upon the data and your understanding on that. Okay, so keeping all these things by like default, like quartic, I don't want to change this for now. Okay, and once you are clear with all these advanced parameters, then after that click on run. Okay, so now based on the radius and all this information that we have used here as input parameters, we got our heat map.